Hello everybody, this is the notes for geometry class, 7th hour, section 1 of chapter 5. What we're talking about here in chapter 5 is, we got done talking about chapter 4, which was congruent triangles, the different types of triangles. And so in this chapter, like it says up top, relationships within triangles. There's lots of stuff going on inside of triangles. There's lots of things that can happen. If you start drawing in some other segments, connecting certain points, you get lots of properties, lots of connections between things. And so that's what we're talking about, relationships within triangles. So in this first section, in blue here, it says Mid-Segment Theorem and coordinate proof. And they're kind of related to each other. So let's first go ahead, hit pause on this so you can copy down the top part of the notes. Don't do the bottom part yet. So hit pause, take a second to copy that down. Okay, so a midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. So if we're looking at triangle ABC here on the right side, we got this point, it's a midsegment, we'll call it point E. It's a midpoint. We got a point here on segment AC, we'll call it F. That is a midpoint. We also have a side, so a midsegment of a triangle is a segment that connects midpoints of two sides. So when we connect those two midpoints, this is a midsegment. It's just a segment that connects two midpoints. Now, remember the definition of a midpoint says that these two segments are equal. Segment AF would equal FC. That's the whole idea of a midpoint. So segment EF is a midsegment. Each triangle contains, well, how many do you think? If we draw in another midpoint here for side BC and call it point G, then we've got a midsegment connecting E to G. We have a midsegment connecting G to F. Remember, a midsegment just connects two midpoints. And so in this one triangle, we have three different midsegments. Okay? Now, midsegments have properties. So let's go look at this drawing here. We still got triangle ABC. It's a little bit different. I have drawn in points D, E, and F. They are midpoints. And so you can see when I move this around, F is staying in the middle between A and C. D is staying between A and B. Whoops, I'll grab the point. And I can move on point B here, and D and E stay as midpoints. So, a midsegment, segment DE. Oh, come on. Why is it not showing? There we go. Segment DE. That is a midsegment. It is connecting those two midpoints of D and E. So if I move this around, it's staying as a midsegment. Now, what I want you to do is concentrate on the information up here. Okay? Those numbers there. Let me move it just so the numbers kind of show up a little bit better. Oh, I had it good. I just want the numbers to be a little bit cleaner. There we go. All right, segment AC is 2.16. Segment DE, our midsegment, is 1.08. Notice as I move point B around, it's not changing those lengths. So the question is, what is the connection between these two things? 1.08, 2.16, the midsegment, it's half of that. And it didn't matter where I move this, it's staying half. If I move point C around, you can see that midsegment, DE, it's still half of AC. Now the other connection going on here is having a tough time getting things to show up here. Oh, come on. Trying to push on some buttons on the side of the screen that you can't see, and they're just not, is not working here. Why is it not working? How frustrating. But what I was going to show you is these two angle measurements. And you can see them right here. These two numbers on the right. They are equal angle measurements. So as I move this around, ignore those little marks I put in there. You can see how those angles are changing, but the connection is they're staying the same. And the ones I've constructed, those measurements, these are corresponding angles. So if corresponding angles are the same, what can you say about the lines? they're going to be parallel to each other. And so the same thing happens, let me clear some of this stuff. The same thing happens, well, I'm trying to draw on these other ones. Gosh darn it. Oh well, I'm trying to draw on the other ones and it's just not letting me click on those points, on those segments. Most annoying. Let me see if I turn this off. See if that makes a difference. Hey, it does. All right. Fantastic. Here's a different mid-segment. Okay, now we're looking at segment DF. So our information is down here in the lower right of the screen. Okay, the number is a little bit off. That has to do with a rounding issue. There we go. You can see DF is the mid-segment. It's still half of that other side, BC. Notice how these two angle measurements here, they are the same. Again, they're corresponding angles. So yes, they're changing, but they're always staying the same. So we have corresponding angles congruent. Again, that implies parallel lines. And if I go to the other mid-segment, there's 3 in each triangle. Now we're looking at the information over here. So again, you can see the length of that mid-segment, EF. It's half of that third side, AB. These angles are changing, yes, but they're staying the same. Again, those are corresponding angles. So what we are looking at is 2 properties. It's called the Mid-Segment Theorem. The segment connecting the midpoints of 2 sides of a triangle is half the length of the third side of the triangle. And the other property was that the mid-segment is parallel to the third side of the triangle. Okay, so that mid-segment, it's half the length of the third side and it's parallel to that third side. That's our mid-segment theorem. That's the property that we want. All right, what I would like you to do is hit pause, try these problems. You're given MP as a mid-segment of triangle LNO, solve for X. So hit pause, give them a shot. All right, I hope it went well. So now, in these problems, you were told this segment MP, it is a mid-segment. So the length of MP is half of the third side of the triangle, which, you know, M and P are connecting midpoints of 2 sides. So we're not looking at those 2 sides, we're looking at the other side, that third side, which in this case is ON. Well, MP is our value of X, it is half of 16. So MP is 8, which is our X value. All right. Looking at question number 2, again, this is a mid-segment. So the mid-segment, which is 7, is half of the third side, which is X. So to solve for X, what we're going to do is multiply both sides by 2. 1/2 of X times 2 is just X. 7 times 2, 14. There's our value for X in question number 2. All right, looking at question number 3. MP is a mid-segment. That means it is a segment connected to 2 midpoints. So point P is a midpoint. That means these 2 segments are the same. X has got to be 4. And looking at the last question, very similar to question number 2. MP is a mid-segment. So that 4.5 is half of the third side, which is our X. So multiply both sides by 2. We get 9 equals X. All right. This is the last example that we'll do for the notes that you're watching here. We got one more concept to talk about. We'll do that in class. So this one, same concept. All right, look at this given information. You're given these tick marks right here and here. That means A is a midpoint. Look at these tick marks, double tick mark, double tick mark. That means point B is a midpoint. So segment AB is our mid-segment. All right, so the mid-segment. Let's hold off on that. The mid-segment AB, it is half the length of the third side, which in this case is CD. So AB is 3x plus 9. That's going to be half of 12x minus 53. Those are the lengths of CD. So now, to solve this, we got a couple of options of ways to solve this thing. We could distribute this 1/2 into the 12x minus 53, but 53 is an odd number, so we're going to be dealing with a decimal. The other option is to move that 1/2 to the other side by multiplying by 2. 1/2 times 2 is just 1. 1 times 12x minus 53 is just 12x minus 53. But now we got to multiply this side by 2 also. So that gives us a 6x plus 18. It just makes the algebra a little bit simpler. It avoids decimals. All right. So move all the x's to one side. So I'm going to subtract 6x. That gives me a 6x here. I'm also going to add 53, moving the numbers, the constants, to the other side. 18 plus 53 is 71. Divide by 6. X is, boy, that is just shy of 12. We'll just leave it as a fraction, 71/6. It's approximately 11 point, I don't know, 9-ish, 8, 9, somewhere in there. All right, that's one of the types of problems that you'll see. Like I said, there's one more concept to talk about. If you want to give this a shot, hit pause, copy down this problem. We'll talk about it in class. Have a good night.